Might as well make a start on it now. So this Unit 1 and 2 class, we're now up to essentially the chapter review for most of the functions and relations stuff. So, you've got your basic tech-free sections, you've got your multi-choices and your extended response related stuff. There's a decent spread of questions to be done, especially given that it's a sequence of many different chapters. Right, like you can see some polynomial stuff, some transformation stuff, and then like sort of later on, we also get into some of the more the questions where you have to sort of bridge multiple concepts. At least that's on the tech-free side. Tech-active, obviously, you've got your more worded problems. Is there anywhere in particular you'd like to start?
No.
Nothing in particular? Sure. Let's give an extended response a crack. Why not? Get a few of these done. Let's have a look. Okay. Family functions, square root, maximal domain of f. All right. See how we go. So it's a bit unique in the sense that there's no real numerical values for our function. So we can infer that our domain's also not going to have any real numbers actually in it. Maximal domain of this root. One of the things you could start by doing. Oh yeah, go ahead.
This yeah, okay, so it's from negative infinity to a.
Yeah, correct. Negative infinity to a. How'd you come to? Yeah, go ahead.
So square root, I take a normal square root function and flip it on the y-axis because x is negative.
Yeah, that's all right.
And yeah, it's up to a. So a is positive here, so it's going to be a translation of a units left. Yeah, that's it, I think.
Yeah. So you end up with, because you take the negative out, it ends up being a horizontal translation. Because a was the positive number, you're shifting it right by a, whatever that is. And so, yeah, as you had it, negative infinity to a. Now that's going to be inclusive there. Fair enough?
Yep.
Nice.
Yep.
Alrighty. Coordinates of intersection between the function and the graph of y equals x. Should we bother with this one? What's it going to lead into? Yeah, why not? So we'll at least get this, we'll get this one written and then we can probably talk about the rest of these more conceptually, if not solving them outright. So where does f of x intersect the graph of y equals x? What are we sort of considering to do for that?
Set the equations equal to each other.
That's it. Y equals x is the same as the y equals root a minus x. X squared equals a take x. X squared plus x minus a equals 0. And then, well, you have the whole quadratic formula thing there. Because it's kind of hard to do the factorizing approach for this, since you don't really know what's going to add together times together. So we'll have our x equals negative b, so negative 1 plus minus square root of 1 squared minus 4a and c, so negative a. all over 2 times 1 equals -1 plus minus root 1 plus 4a over 2. Yeah. Cool. Okay, and we know that a is a positive number, which is why that has a valid set of solutions there. Awesome. Now, as far as answering these follow-up questions, what might we be interested in doing there? So, for instance, for what value of a does the line intersect at 1, 1, rather than just where do they intersect? Actually, I guess we didn't really fully
Oh
finish
yeah,
this
we
answer.
just
I'm
yeah
noticing from the graph, right? If you had the line of y equals x, you only have one possible solution. What should I have done to fix this one up?
uh, let's just solve it all the way through, or
Solve it how? So essentially, like what we've done here was equate the line y equals x to my root. And if we go through the whole procedure, assuming I didn't make any stupid mistakes there, we ended up with a plus minus, so 2 solutions. But if we were to plot both of those graphs on the same axes, we would see there's only supposed to be one. So we could either consider what's happened, and if you already know what's happened, how could we probably fix it up?
So I guess the discriminant will be 0.
Discriminant 0.
Because there's only one solution.
Yeah, you want to force one solution. What's up with that? This has got to do more so, I believe, with when I covered roots last time. Remember, we had that issue where sometimes solving for your x-intercepts, I think it was, you would get sort of a ghost intercept. Like, for instance, if you had like the negative here, right, and then you brought the negative over and then squared both sides, that negative would kind of disappear. Part of the reason why we're getting double solutions is because, technically speaking, squaring is not the opposite of the root, I think, is the issue. There's like some mathematical reason why they're not exactly inverses of each other. So by squaring both sides, you're not taking into consideration this is only a plus or a minus. In this case, it's only a plus, which is why you end up with double the solutions that you expect. What I anticipate has happened is one of the solutions is the valid one we wanted to have, and the other solution that we found, if you remember from when we covered roots last time, would be whatever the negative version of that root was. Hey, Tom.
Oh yeah.
Hey Chris, sorry, I just joined. Which question and what topic are we doing now?
Yeah, no worries. This is the Unit 1 and 2 Chapter 8 review, so covering basically everything, and we're currently up to 1C here, working on this root. And we've done part B to get to our this sort of x equals quadratic formula thing, and we're just now explaining why, even though our graph would suggest only one intersection, why we end up having 2. So I know you sort of came in late on that one. Did you catch the explanation for it?
No.
No? Okay. So it's got to do with basically, do you remember last time we were looking at roots where sometimes if you solve for x-intercepts, you would kind of get like false positives?
Yeah.
Yeah, it's basically exactly that.
Okay.
Which is the real root that we wanted was this this leftward facing one, and that has one solution. But because when you go through this whole squaring side of things, you neglect that you're only taking one part of that. And so what I would suspect is going to be the negative root is this solution and the positive root is this solution. So basically, you would only want the positive of that, not the negative.
Okay.
That's all fair?
Yep.
Cool. Okay. Nice. Actually, is that the full answer? That's not even the full answer, actually, because that's just the x-coordinate of the point of intersection. Getting the y-coordinate won't actually be as crazy. So let's circle back to B, just making sure we're fully
Wait, are we
answering
on 1B? Sorry.
Yeah, we're kind of circling back to
Okay.
1B just to fully explain what was going on, because I kind of missed it a little bit. I missed that there was a plus minus here. So we're sort of circling back onto that. Currently, we found the x-coordinate of the point of intersection, but it says find the coordinates, plural. We want both. So what's how are we going to get that y-coordinate?
We sub the thing in.
That's it. Yeah, we got some x value, and although it's a nice and big complicated x value, it is still just some number, because a is just some known coefficient. And what we solved was the x-coordinates of the intersection between the line y equals x and the root. So we could sub into any of those graphs. One of those is significantly easier, which is going to be just y equals x. So in other words, both the x and the y are this as well. So your coordinate is just this twice. Nice and easy, as opposed to shoving it in the root, which would take a lot longer to simplify. Cool. So we have our coordinates set. Now we can move on to 1C here. So part B got us to generically find just whatever the point of its intersection would be for any version of f of x with that line y equals x. Now what we're doing in the next couple of sections is trying to figure out, okay, basically more or less what impact does A have on the location of where the coordinates of intersection are going to be. And again, you'll notice they're all 1, 1, 2, 2, CC, they're all the same thing because it's still just intersecting the line y equals x. And essentially, we'll find that different values of A will get us a different set of intersection coordinates. Let's have a think about how we're going to, even if we just start at C, right? What value of A is going to force those coordinates to be at 1, 1?
We just sub in the coordinates.
Yeah, that's right. So we've got these x and y coordinates purely in terms of A. So if we know that they have to equal 1, 1, then all we're going to do is sub either the x or the y, or both if we really wanted to, as 1. Because they're already duplicates of each other, we're obviously not going to do twice the work for no good reason. So rather than having x is equal to all of that, we now have 1 is equal to all of that. 1 equals -1 plus root 1 plus 4a all over 2. And then obviously there's going to be some rearranging there. I'll continue to rearrange that in a moment if we want to see the full set of solutions for that. But you can imagine if we talk about stuff like part D, right? What's going to force it at 2, 2? Well, exact same idea, sub in 2. What's going to force it at CC? Well, that's where we're going to start having to think just a tiny bit harder. So I'll continue to write out the solution because what we end up with might matter for part E. Let's have a think about it in the meantime. So multiplying both sides by 2, adding 1, clearing both sides, subtract 1, divide by 4. So in this case, at least for part C, to force a coordinate of 1, 1, we know we had to have A equals 2. I think the intention of D is to show that if you do the exact same sequence, you get a slightly different A value, and then you can sort of determine what it's going to be from that pattern. But I guess we'll see. Taihan, you got a question?
Yeah, for a question like C, which I feel like you could kind of just test the value of 2 and you just kind of pretty obviously see that it would match. Would you still have to show out all of this working?
As in like just testing guess and check values of A into f of x and see what the
Yeah,
coordinate will
for a
end up being.
question under part C.
Yeah. So why is it obviously 2 for A?
Sorry?
So why is it, as in, are you saying it's obvious that it's 2 to guess and check, or are you saying you just would guess and check some integers?
I mean, I feel like I would probably guess it 2.
Yeah, okay. So
Because
what was
if it's
your,
intersecting at 1, 1, then you know the x coordinate's going to be 1, so it's minusing 1.
if it's intersecting 1, 1, then you know the x coordinate. So you're
Because if
saying
A
that
is
you understand
A
that this
is
is always
2
1.
minus 1 and then root of 1, you just get 1 again. Or am I thinking it the wrong way?
Oh, right, because you're subbing in x equals 1, y equals 1, and then subbing and then finding out which value of A gets you there.
Yeah.
Yeah,
basically.
that's okay. That's fine. Yeah, I thought you
Yeah,
were
I was
just
wondering,
sort
like,
of.
would you still have to show, like, kind of the working out that you did? Or would it be fine if you just did it that way?
Yeah, no, that's fine. Because you still are showing working out actually. Because what you're doing is you're doing y equals root a minus x, 1 equals root a minus 1, and you know you're kind of just doing the solution here. 1 equals a minus 1, a equals 2.
Yeah, that's basically how I
Yeah.
did it.
So that's perfectly fine. Because what you're essentially making use of there is the fact that sure, 1, 1 needs to exist on both functions, but because it exists on both functions, I don't really need to care about the second one. I can just use the first one and just be perfectly fine with it. So yeah, you can just straight up use f of x for that. I just kind of fell into the same old habit of like, well, okay, we got this answer from part C, so we typically use the answer we had previously. What you've done is perfectly fine. In fact, it's more insightful to do it that way because, as you can see, it saves you a bit of time. So
Yeah, I got that. I just saw it, so that's what I was thinking. Like,
yeah, no, that's sick. Good job. Because you already know ahead of time from part C that they're gonna intersect.
I've had a different thought on this, like different way of thinking.
Go for it.
So yeah, I would also guess it's 2 because normally in a square root function, if you put 1, it will be at position at x coordinate 1, the y value is also 1 because square root of 1, that's 1. Well, it's plus or minus 1, but yeah. Yeah, anyway, so as it's 1, 1, if you flip it and move it, you'll eventually, like, if you start if the vertex or whatever it's called is on 2 at position at x coordinate 1, it will have a y value of 1. So yeah.
Yeah, no, I think
that was my thought process.
So to try and put it into pictures, basically you've understood, I think that you've understood that the square root normally has some coordinate 1, 1 when it starts at 0. So flipping that this way is going to end up intersecting the same spot. Is that what you're suggesting?
Kind of, yeah, like flipping it, then translating.
Yeah. So essentially it's sort of like flipping it across there, or flipping it here and then translating to get to the same.
Yeah, I mean it moves away 1.
Yeah.
So as it's flipped, it's going to go back 1 at like 1 x coordinate, 1 point or 1 x coordinate value away. Yeah.
Yeah. No, precisely right.
Okay, this brings me to another question. So if the question does not specify how we need to solve it, can we just solve it anyway as long as it gives us the right answer?
We solve it anyway. Looking at the
Yeah.
marking scheme would be a good idea. If it's a one marker, you just give the answer, and you don't need to show any working realistically. If it's 2 marks, I would be very hesitant to do this sort of thing, because this should count as working to kind of be like, okay, you're showing the assessor, if you at least draw this graph for them, you're showing the assessor that you're thinking about the translation and reflections of a certain function and then coming to your conclusion. I would say that's slightly riskier than doing maybe like the next easiest thing, which might be this. But yeah, it'd be more so checking the amount of allocated marks for it, because at least as far as SACs go, they do have a set mark allocation for things, and part of those marks, if they are more than 1 marked, is working out. So whatever you can do to show what's going on in your brain on the page will definitely be better than nothing.
Yeah, it's just that in the past probably sometimes I would not study for the math exam, but I would be able to reverse engineer the question. So
yeah, sure. Yeah, basically whatever you can do to show some level of what's going on in your mind on the paper will serve well. Obviously, the ideal is making sure you're doing a decent amount of working for your stuff and knowing what's not necessarily the intended solution, but a very solid sequence of logical steps to get to your final answer. But again, like, answer is answer. If you get there, you get there. So that's this sort of stuff is almost secondary. As long as you're showing enough working in some regard, then you should be fine.
all right.
Yeah, Tyler?
Yeah, I was wondering, the thing I was doing before with part C, would you be able to do the same for D as well?
Okay. Yeah. Oh, hang on. Yeah, because you're assuming, again, it's
If A was
passing through
6?
2, 2. Yeah, because you're passing through 2, 2. If they intersect at 2, 2, then it should also exist 2, 2 on the f of x. Yeah.
Yeah,
Your approach
cool.
works perfectly fine there as
But
well.
the working out, like, I just have to write out the working out, like the part that
Yeah.
you've circled. I just
Yeah,
have to
so you're
make
just
sure to
doing
write
this
that.
now.
Okay.
So that'll get us to. Oh, sorry, that's about to be squared. So 4 and then 6. Yeah.
Yeah.
Yeah, it's just exactly showing that working out, because the 2, 2 one is a bit more, a bit harder to immediately rationalize as your value to put it directly on the paper. So yeah, doing some sort of little thing like that will help. Which will help even further probably for CC as well, because again, this is the same question just with C's in it. So once again, whoops, let's make it in green. C equals root A take C, B squared plus C equals A. Yeah, that's it. C squared and then plus C on both sides. What value of A is? Yeah, where C is a positive real number. Yeah, doesn't seem like anything is wrong with that. So it's the same sort of idea. As we can see, significantly quicker than if you had used the whole plus root thing going on. But both should get you to the exact same idea. Could probably maybe also look at a pattern, but I doubt it. Because if you keep doing this over and over again, like 2, 2, 3, 3, 4, 4, there is a certain pattern in the sense that you're squaring this and then adding another copy of the number. So like 1 squared plus 1, 2 squared plus the 2, 3 squared plus 3. There is a pattern for that, which is described exactly here. Number squared plus the number. Funny how that works. Anyway, that's a nice little sequence to go through then. Yeah, go for it.
Wait, just quickly, implied and maximal domains the same, right?
Correct. Yeah, they mean the exact same thing. Maximal domain, implied domain. Because implied domain is more so used when they just haven't given a domain for it. There's an implication for what it would be. A maximal domain, you basically, the implication is always to maximize. But yeah, nice. Let's see what else we got. Is this just going to be, let's see, selling plates at $11.50? Dear Lord. Cost of production has an initial cost of that, and then that per plate. Plastic plates, $10.50 per plate? Cost of manufacture? Dear God. Plastic? Alright, whatever. These are somewhat common. You usually see these in more so like your SACs and your chapter review sections, so it's definitely worth going through. Less exam stuff, though, I would say. Let's have a think. So C is going to be our cost, not our income. So in terms of just pure cost on our plates, we're going to write it in terms of X, where X is the number of plates. What's our cost equation going to be based on the information provided? Yeah, go for it.
Yeah, would it be, wait, so it would be, because it's an expression for C in terms of X, we would write it as C equals and then whatever, right?
The equals whatever. Yep.
Yeah. Okay, so it would be C equals 3,500 because that's the initial cost.
Yep.
And then it would just be 10.5x.
Yeah, 10.5x because C is in dollars. Yes, that should be fine. Plus 10.5x. Yeah, exactly as said. So just the cost of having the factory run at all is your 3,500. And then for each plate, which is why that's got the variable on it, X, each plate that you produce adds an additional $10.50 worth of cost. Yeah. Easy. Yeah, always paying attention to units here matters quite a bit. If it was in cents, we would obviously have to change things a lot. And then knowing that X is actually in terms of plates definitely matters quite a bit as well. What's the other thing about this? There is another, if we think about like the implied possibilities for X here, actually, do they cover this at all? Kind of. They cover it in like part D. What are some real world limitations on X, given the scenario we have here? They're not asking it, but it definitely helps to think about this as a real world scenario. What are some limitations on X?
It has to be a positive real number.
Positive.
I think it's going to be an integer.
Yeah, integer, positive real number. Both of those are mostly all the way there. Definition of real number includes...
Oh, sorry, a positive whole number.
Positive whole number, yeah, that'll be the closest. So the reason why integer is a little bit inaccurate is because integer includes the negatives as well as the positives. So the ways you could give it, positive whole number, like you said. Natural numbers, by default, covers all the positive whole numbers. That'd be the other way. And also you could have positive integers, right? So you could have double-stroked I and then plus. Just like how you can have real positive. You can have I positive, or you can have just n natural numbers. Either of those two would be fine. Maybe you'd have to actually hang on. Natural numbers, that includes 0. Double check. Pretty sure there's going to be a union of 0 here. Although, are we going to actually do that? Because technically speaking, you probably just don't run the factory if there's no plates being made. That's a bit more ambiguous because it's not technically stated that the 3,500 of the initial cost has anything to do with plates being made. So it's kind of hard to say whether a 0 should be included or not. I wonder if the book...
I've got a question. Do we need philosophy to do good in math?
Say again, sorry?
Do we need philosophy to do good in math?
Many philosophy, yeah. Unlikely. Yeah, but knowing... yeah.
I guess like being able to think critically about questions, that's going to be pretty useful.
It's going to be 100% useful for this, because like basically as far as I'm concerned, methods is the critical thinking of how you use the equations that are given to you. Because if you
But-
think about what's
Yeah, so what's specialist then? I-
specialist, well, just
I
that to
haven't
the
taken
extreme.
special.
No, that to the extreme, basically. You're starting to learn even more concepts that you
Yeah,
try to
that's
link
it.
together. You do a lot more of your differential calculus. You look at more complicated graphs and their relationships. And effectively, at least I can definitely say as far as methods are concerned, but I've seen special exams as well. They're basically the same thing, which is when you get to that tech active or even some of the tech freeze, all you're really doing is trying to figure out what information do I know that links all of my key information together. So basically, you know, we had this sell price, we had a cost, and we had another cost. What we're essentially doing at all stages is essentially trying to figure out what information do I know personally that can link all of this together in a neat and succinct way. Did I do special in year 12? I did not. I probably should have, because when you get into university, you basically do a crash course of spec if you do like an engineering degree. At least that's what RMIT got us to do. But no, didn't do
I
spec.
took special for like a few weeks, but I dropped out.
Yeah, that's
I might be regretting it because what I did take was business management, and I don't think that was the right decision. But yeah, I
it's-
guess I would have loved special.
I mean, you get away with it. Like I didn't take
Yeah.
spec either, and I don't necessarily regret it too. Like it's not a big deal. Because when you get into uni, your workload is strangely less, at least as far as your math and technical skills and stuff like that go. You start learning new and different things, and so your workload for school-ish feeling stuff is actually quite low. So it doesn't take too much effort to get you back up there, so long as, of course, you did decent in methods. Do not do special, not worth it. Yeah, that's fair. I know a few people that did it and kind of crashed, but yeah, to each their own. It's definitely a high scaling thing, so if you can hack it, go ahead. But I didn't, and I ended up all right. So even if you don't end up doing it, you'll still do all right. Okay, anyway, so carried out a cost equation. The next one is now going to be the income. So again, definitions here. Income is going to be prior to cost. So we're not looking at like profit necessarily. In fact, you can almost see ahead of time what that's going to be, even though they don't necessarily state it outright. So again, yeah, income is going to be prior to cost. So if we think about our income equation, what's that going to end up being?
Is this for the income equation part B?
Part B, correct.
Yeah, would it be income equals 11.5 times X?
Mhm.
So that's your, I guess, revenue.
Yeah,
And
you
then
could, that more accurately be called revenue for this, yeah.
yeah. And then minusing the cost equation that we had before.
So for part B specifically, we're thinking of income as the same as revenue here.
Yeah.
And so when you get to profit, yes, you'll be doing the subtraction of the cost equation.
Oh, okay.
But
Yeah.
when we get to the income, it's just going to be the pure revenue created by the selling
Okay.
of plates.
Yeah. I just thought about it like that way.
Yeah.
But
No,
yeah.
I get you.
So it
I
would
also
just be
kind of-
11.5x.
just 11.5x. Yeah, absolutely.
Okay.
Next up is the sketching of these things. I mean, as long as we're both happy enough with the fact that these are both linear, this shouldn't be too big of a deal. This is extended response, so technically this is also CAS enabled as well. We can already get a rough idea of what these graphs are going to look like without doing too much. So 11.5x is going to be a nice and steep thing, slightly steeper than whatever this is. So let's say this is our 3500. We'll draw a slightly less steep line with the vertical translation of the 3500. That'll do for now. We don't necessarily care about anything going on here because, as we said, our x values, well, there's no, we're not dealing with any negatives here. We're only looking at the positive side of things. So we can imagine that this is probably going to be a key feature. Oh, yeah, no, it is. Part D. That's exactly what Part D is asking. How many plates must be sold for income to equal cost? So again, just by looking at the graph, we can see this one is going to be the income, This one is going to be the cost. So if income equals cost, well, there's your key feature. We've kind of already discussed how to find intersection between points, between curves. Just make these two functions equal each other. 11.5x equals 10.5x plus that, solving for x. We also talked about E already, which is the profit. P equals I minus C. They're literally telling you exactly what it is. And the question is technically asking what does P represent, but again, we've already talked about this. P is going to be the profit. Finally, how many plates must be sold for a profit of 2,000 to be made? I'll start creating that profit equation. In the meantime, let's have a think about how I'm going to answer that final one, part F.
Couldn't we just gone directly to that, the profit equation? So yeah, I mean, like, the profit is just $1, so 1x minus the cost of starting the thing,
Oh yeah,
so minus 3,500.
Whoops, yeah, should have that 0.5 there. That was me being stupid. Yeah, so you can go directly there without doing the literal equation that I've written. They did kind of tell you to do it in part E, but if they didn't tell you specifically, hey, do this, then yeah, you could be like, cool, I can see just based on my sell price and my cost that my gross margin on that is $1, and since I've spun up a factory for 3,500, then I've got to have this offset of 3,500 in the red before I get there. So yeah, you can logic your way into that totally, but as far as like word for word what the exam, in quotation marks, has written, you wouldn't want to do that because it told you do it this way instead. But yeah, you're right, you could rationalize it.
Okay.
And then yeah, how many plates must be sold for a profit of 2,000 to be made? Well, you know, P equals 2,000. Nice and simple. This one actually ends up being a whole number anyway. So, you know, some of the times when you do this, they'll choose a number that is strange and like a decimal or something like that to throw you off. Assuming we did get an X of like, I don't know, 20.9, not anywhere close, but just for the sake of argument, we cannot have a decimal number of plates, right? We're only dealing with whole numbers here, personalized. What am I saying? The number of plates has to be a whole number. And so how many plates must be sold for a profit of 2,000 to be made? Typically, what they'll word it in the way, they'll word it in a way where it says a minimum profit of $2,000 to be made. In which case, what kind of rounding are we suggesting here? We do need to round it at least one direction to get that whole number. If we want to make a minimum profit of $2,000, and assuming this was our X value, what way are we going to round this? So in other words, if this was our profit equation, profit graph, and 2,000 was there, and it came at specifically 20.9, just hypothetically, and we wanted to have a minimum profit of 2,000, we need to round this one way or another. We're rounding this number up or down, and why?
I think we're rounding this up.
Rounding it up. Yeah. Why is that?
Well, it's a minimum profit.
That's it. So if you round up to the 21, you get the number slightly above 2,000. Whereas if you round below down to 20, you get the number slightly below the profit that you're asking for. It's pretty common for them to do a thing like that in these questions. They didn't do it here, but I've seen it happen quite a bit. Wait, is there anything to clarify about how that's worked? In the meantime, I'll see if I can find a nice unique.
Sorry, what was the answer for part F again?
Part F I just didn't finish. It was the rearranging of this, right? It said profit for
okay.
2,000, so you just sub in P equals 2,000. So what's that? 3, 4, 5, 5, 5, 0, 0. That's the actual answer for it. I'm just sort of doing the hypothetical of the slightly more tougher versions of these questions where they get you to also round on top of that as well. So yeah, the actual answer for F is going to be 5,500. Okay. Is this going to be any interesting? Part 3. Tank has capacity, water flows, rate. Yeah, maybe actually, because you got to really keep track of what the units are in this one. So let's see if this is any interesting. The tank has capacity of 1,000 litres, but is initially empty. We're flowing water into the tank at a rate of 20 litres per minute, and we're doing that for a total of 10 minutes. The rate is then decreased, and at that decreased rate, it will continue to flow until the tank is filled. Part A, how much water is in the tank after 10 minutes? That one shouldn't be too bad, at least initially. How much water is in the tank after 10 minutes?
So after 10 minutes, it's I guess it's quite easy. We just multiply 20 liters per minute for 10 minutes.
Yeah, exactly
So
right.
200 liters.
Yeah, 20 litres for per minute for 10 minutes. So for each minute is another 20 litres. 20 by 10, 200. Yeah, 200 litres, final answer. Nice. Now, we're going to be doing very similar things to get our full volume equation. Let's have a go. We've got V. First one is described by AT. Second one is described by BT plus C. So what we just did is going to be relevant. Let's see about the rest
Sorry
of it.
again, Chris. What was the value for question part A?
That's going to be 200 because it's 20 litres per minute for a total of 10 minutes.
200.
So
Yep.
20 by 10.
Oh, yeah. Okay. My bad. I see that now.
No, you're good. You're good. Okay, so that was 0 to 10 there. And then this is 10 to D. Okay, so our goal is to figure out all those coefficients, A, B, C, and D. This is first a volume equation, so note that everything in here is describing the volume of the tank itself, volume of the tank, the water in the tank specifically, actually. They didn't actually give a definition for T, I don't think. Do they define it anywhere? So we're going to assume minutes for this. Yeah, it's just flat out not defined anywhere, which is bad practice. The actual exam at SAC should definitely define the units for you. So we can imagine why there's a piecewise for this. The fact that we're splitting it up into two separate parts is because we have two separate flow rates. two separate like scenarios in the sequence. So we can pretty much infer that one's going to go to the first part, the other's going to go to the second part. So AT, what could that potentially be referring to?
The first 10 minutes.
First 10 minutes, yeah. And that's especially true because of the domain associated with it, 0 to 10. Which I guess is another way you can infer that T is defined as minutes, but typically even with that, VCAR will still define what T and V are in their units. But yeah, absolutely right. So based on that, AT, we could probably figure out what A is going to be. What's it likely to be there?
20.
20. Yeah, exactly
20.
right. Yeah, both of you got it. Good. The flow rate of basically any coefficient for our linear is going to be the rate of change because it's our gradient of linear. I'll start writing that one out. In the meantime, let's have a think about either B, C, or D, whatever's easier. Or even maybe you might have to do a slightly different approach to get them all. Bit trickier. One of those coefficients can be solved more or less the same way.
B is going to be 15.
B is going to be 15. Once again, our rate of change is going to be the coefficient of our linear. Yeah. 15t. We've got the C and we've got the D to deal with here.
For the C, the second rule has to pass through 10 to 200 if you think about the coordinate, I
Yes.
think.
Exactly right. This is the part that even I've messed up before, which is, yeah, you need to have them join up.
So what I was thinking here, you would just write it as 200 equals 15 bracket 10 plus C, I think.
Yeah, because you're basically saying 15t plus C should force 200 at the x equals 10, or t equals 10.
And then, yeah, C is 50.
Exactly right.
And
Plus
D,
50.
I'm not really that sure.
Okay, that's fine. Have another reread of all the key information. You know, we got this 1,000 liters, we got this 20 liters per minute for 10 minutes. Basically, all of the key information is usually numerical. Typically, it's there for a reason. So if you haven't used it yet in any capacity, it's a good idea to start figuring out how might I use that last bit of information.
Do you have a hint for D?
I do. I said the word capacity. Also this one as well.
Wait, I think would D be? Oh no, D would be because for the first part it's 0 to T and then to 10, which is kind of the time.
Yeah.
So D is just another time value.
D is another time value, correct? Yeah.
And would it be so? D is when the tank's full, right?
The time at which the tank is full. Yes.
Okay. Oh, okay. So would it be then? So if we substitute 1000 for V,
1000
and then
for
you
V,
get
yep.
1000 equals 15t plus 50.
1000 equals 15t plus 50. Yeah, that's absolutely right. Definitely using that second one because, well, that's the one that's part of this domain.
So that's like 190 over 3, I think.
190. Oh, let me double check. Oh, yeah, whatever this solves into. Doesn't really matter what the number is as long as you solve for t. Yeah.
Yep. Is that right though?
Let me check. So we'll do 1000 minus 50 divided by 15. Yeah, you had it right. 190 over 3. And that's going to be our D there. Oh, that's inclusive. What am I doing? I mean, either way, the question said find A, B, C, D. So rather than fill this out, technically what they're looking for is A equals this, B equals this, C, D equals those. But yeah, so that's a little bit about formatting your answer at the very end. Don't really do what I did necessarily. Just at the end at the very least, make sure you're writing out what all those coefficients actually are at the very end. But yeah, nice. So some take-home messages for that. Basically, when it comes to linear, any rate of change information is going to directly correspond to the coefficient of the linear, because the coefficient of the linear is the gradient of the linear. We also talked about how piecewise, especially when they're talking about applications, have to join at each branch always, because there's very, very, very few applications where it's going to have a discontinuous function. So making sure that we're choosing our coefficients to join at each of those points is really good. And then finally, yeah, this last little bit about time. It's got a, firstly, the thing is time because it's in a domain. It's in the T section of it. And secondly, how we get there is going to be based on some other, not necessarily as immediately available. Well, it's available information, but it's not information we're typically used to using as much. Sketching this graph is just sketching it piecewise, or in other words, sketch two linears from 0 to 10 and from 10 to 190 over 3. I would hope we're all fair enough on sketching linears. Maybe we might want to do a bit of a recap on how to do it on a CAS. So, assuming you guys have the TI Nspire, the piecewise function is actually a particular button for it. Where's that gone? Well, I missed it. What's the piecewise button? I've seriously just forgotten where it was.
I think it's near the book there.
Yeah, I could have sworn it was near the top. It literally has the look of a piecewise. Why am I going blind?
It's beside 9.
No. Oh yeah, it's literally just that button. Jesus, I thought it was a control button for some reason. Yeah, cool, thank you for that. Yeah, it looks literally like a piecewise. And the one that I'll typically use is this one here, because it lets you set the number of things for it, whereas the one next to it is just default 2, which is fine for this, right? Default 2 is what we needed. But at least this way you can set the number, and rather than doing it in the calculator tab, you can do it directly in here. Basically, it's just going to be function and then domain exactly as you write it with the solve. Right, so you'll do like 0 less than or equal to x less than or equal to whatever, and then you just fill them out exactly the same way there. So just for the sake of it, let's do the one that we had. 20x, and we had 15x plus 50. And less than x less than or equal to 190 over 3. I don't think it's going to matter too much if you use like doubling up on the double or on the equal signs in there. I don't think it's going to break, but it might though, and it's good practice to remember what's part of it and what isn't. Now, obviously, as far as the scaling of this goes, I like to be a little bit out of the boundaries that we were given. So what's 190 on 3? Let's go like 200 on 3. And then for y values, you kind of just eyeball it. Or I guess in this case, we know the capacity is 1,000 anyway. So I don't know. Let's do this. This one here is kind of in the way, but you can see it's got that little elbow where it goes up and then a little bit more flatter. The rates of change are pretty similar, so it's hard to see exactly, but especially if this thing in the way. Can I move this? Doesn't look like it. Anyway, there is an elbow there. Cool. And you can actually like, flat out use this in your CAS solves as well. Like if I tell it to solve for like f of 15, for instance, it'll actually use it. It'll know which function to use because of the domains that are associated. You can even diff them. And as we expect, it comes out to be two constants because it was two linears. Oh, does it even handle? It does. Look at that. See, if for those who are here for the diff stuff, remember that when you diff these piecewise functions, at those joins, because it's instantaneously changing gradient, we can't necessarily give the gradient to one function or the other. So what you'll notice is they've actually stripped all of the equal signs from those inequalities. So it's all just less thans and greater thans. So that's kind of cool. The CAS actually also does that as well. A nice little bonus there. Yeah, go for it.
Yeah, wait, actually, how do you put it into diff for piecewise on the CAS?
Yes, that what I just did there was the shortcut shift minus to get diff.
Yep.
You can get it from calculus menu as well. And then all I've done is, because it was already defined as F7, I've just used F7.
Oh, so, okay, so you can just define the piecewise as just f and a number, and then when you put it into diff it, you just write that same thing.
Yeah, I mean, oh, right, because I think, yeah, if you try to do it directly in here, is it going to break? Well, I guess not.
Okay, yeah, no, that's what I was wondering, like if it still works or not.
Yeah, this should still probably work. But if not, again, just define it elsewhere, and then it's good practice to define them anyway before you put them in there. So
yeah, I feel like that's easier anyway.
Yeah,
so.
better off doing it that way instead anyway.
Yep.
Okay, not too much time left. Let's see if there's anything that I should show. This one is very standard, right? You got this whole maximizing the area of a box and the whole sequence of stuff like that. We've done that to death. Height, horizontal distance, max height. That should be all right. More rectangles and maximizing areas and volumes. Stuff like this, what you're essentially always trying to do is get your missing lengths and then just sort of break down the shapes into shapes that you do know. Like there's no generic area formula for this whole thing in one go, but there is a formula for rectangles and squares. So if you just sort of draw out what the individual missing lengths are and then cut them off at certain bits, whether you go like horizontally here or vertically here to create either rectangle, doesn't really matter, and then just adding those up at the end. Like just as a quick example, you got y as the whole base at the top, you got x as this little bit here, so whatever this bit here must be y after x has been taken. Similarly speaking, for the back bit here, you got 10 and you got x, so whatever the whole back of this is, it's going to be the 10 plus the x. That's going to get your perimeter part, which again is very classic for the additional information you get for area maximizing things. You get like a perimeter related thing. In fact, you pretty much always get a perimeter related thing. Twice as high as it is long, so that's again like relationships between the length and the width. Length, yeah, it's usually perimeter related. What else? These are also kind of common. So you get functions that are describing the physical location of a thing, more so specifically going to be the vertical position of it. So when you have like we had it here, right, which is y of x, this one is both the vertical and the horizontal, because y is the height above and x is the height, x is the horizontal distance. That is different to this one that we have here, which is h of t. The horizontal is now t time. So h, at least in this one, as described, is going to be the height, but where does it say it? There you go. Function is describing the height. So there's a pretty common mistake there that people run into, which is assuming that whatever graph they've drawn is always the path of the thing that's moving. It's not necessarily the case. So just keep that one in mind. Sometimes it's time, sometimes it is horizontal distance. This one is going to be some sort of piecewise, I imagine. It's the same sort of thing we were looking at before. Cost-related stuff. Volume once again, but this time we've got variables. Yeah, they're all quite similar. These are also worth doing, the investigations, which we might have to do in in the Friday class, the review, because these are relatively new to the study design. I say relatively because it's been around for 2 or 3 years now, I think. That's definitely a far cry from the 20 or 30 odd years that methods has existed. So there's not a whole lot of information out here for this. In fact, if I recall, I'm pretty sure only no, sorry, that's pseudocode I'm thinking of. Point being, they don't do a whole lot on investigations, so whatever you can get your hands on is pretty good, because those tend to be weird sacks because no one really knows how to write them just yet. So you've got the Cambridge stuff for that. Jacaranda hopefully has some. And if you check my modules at the very bottom with the SAC module, something like that, you'll have an investigation section, which is essentially all the past students that I've personally taught. I've got my hands on whatever they had for investigation SACs, and I kind of just put them all in there. You'll notice there's quite a variety of stuff there. That's not to say that you'll get a variety of stuff. It's more to say that you'll get maybe something that looks like one of those things. It's really hard to say what your school's going to do with it specifically. Yeah, you got a question?
Yeah, should I like, if I get anything from school, should I just like send it through? Like, I'm not sure if we can like, I can share it, but just if I can get any advice on that.
Yeah, no, go for it. Whatever. Yeah, absolutely.
No,
As you get
probably not
closer
on
to
me
the-
now, but like I'm saying, yeah, once I get closer to the SAC.
Yeah, sick. Like that goes for everyone, by the way. If you guys are getting closer to SACs or whatever, absolutely make use of the form submission thing for each of these classes. Right, like I'm more than happy to run a full class on something that's really relevant to you when you're going into a SAC, because that's going to be what matters most. Because like realistically, I've done a full year of these already. Like if you want to watch lessons on these things, you can watch them as past recordings. So if we can do things that are relevant to you right now, that'll be the most effective, I think. But cool. That'll be about it from me. Is there any further questions? Happy to stick around for it. Otherwise, thanks for coming. Ooh, go for it.
Yeah, I have my like updated planner for the year.
Hmm.
I thought I'd just share that with you
Yeah, I'll see it.
if you have some time.
Yeah, I got some time.
Let me know if that's come through.
Oh yeah, okay, full download, sure. Let me grab that.
Yeah, I'm just seeing this now as well, but because they've just sent this to us, but I just wanted to see kind of checking like where we're at right now.
Yeah, we're looking at 11th May. Oh, exactly 11th May. Cool.
Because we've pretty much, I don't know, we've pretty much done
Yeah.
integration.
Yeah, well, we've done all. Yeah, we're finished integration now, which is there you go. Integration by recognition. We've done anti-diff at that. We've done that. Yeah. I don't
Yeah,
really
'cause
know
I was
why they
wondering-
bother splitting these up, but mainly because of
Yeah.
the chapter sections.
Yeah, because I was wondering if we could go back over chapter 11 for integration, because I just really wasn't feeling that great with the whole thing, to be honest.
Yeah, as in just like straight from the start, or
Yeah, just like a quick review, like going through all the different parts. Like I think I kind of get it, but not fully, if you know what I mean.
yeah, okay, we could do I could make it for that for the Friday, just sort of doing a like full overview of it. Actually, maybe I'll check what it is currently. I'm pretty sure we've only just finished the integration stuff, so it might just already be on the on the calendar to do that. Let's see.
Yeah.
Integration. Yeah, we're looking at doing not just integration, but like a full calculus review of everything. So more than happy to focus on the integration side of things for that.
Okay, I mean, no, that'll be fine. I feel like probably covering all of like, or not covering, but kind of reviewing all of diff and integration would be really helpful.
Yeah, and that'll happen actually tomorrow as well. Like so, because the review class is obviously just a kind of a duplicate of these two.
Yeah.
So yeah, that'll happen tomorrow as well as on the Friday.
Okay.
Sound good?
Yeah, I'll let you know if I have any like specific questions. But yeah, I thought I'd just show you this quickly.
Yeah, just flick that to me whenever you get a chance, whether it's tomorrow or the Friday. Either's fine.
Yeah, I'll see if I'll submit something to the form. But yeah, I've got a couple of sacks this
Yeah.
week, so
Even if you
easy.
send it direct to me, like, that's fine. Whatever gets it through, if it's
Yeah.
easier.
Sounds good.
Yeah. How far do we get?
Thanks, Chris. Oh, sorry, that's all good. What were you saying?
Yeah, I was just seeing how far we are ahead. So we've done all of this. Area between curves, applications we looked at. Yeah, we're at least 2 weeks ahead for you. But obviously we'll review it. But yeah. Sweet.
Yeah, I think when does it say our sack? Does it say it on there when our sack is 31st of August? Oh no, that's the Unit 3 sack. Hold up. 15th of June is going to be my sack on DiffCalc.
Not too long away, eh?
Yeah, because I don't know. I've heard that they're basically just going to sideline like the first couple of chapters and just kind of focus on calc.
Yeah, it's because they kind of just get implied in there anyway. Like, if you think about the first couple of chapters they are just linear quadratics and then polynomials. Well, actually, no, I think in the Unit 3-4 they do the MISC graphs, the hyperbola.
Yeah, and there's also like trig, dude. I feel like it's just going to kind of combine the basic stuff, but then just integrate that all into calc questions.
Yeah.
That's my feeling.
And
And I'm pretty sure it's all tech active as well. So
it's all tech act.
Yeah.
It doesn't look it.
oh no, that's the review. the
Oh
one
yeah,
that
that's
you've got
sorry. Yeah,
highlighted
you're right.
there.
You're right. Yeah, I'm looking
Yeah,
at the
but the
wrong thing.
sacks, I don't know, because for our sacks they make it like all of our sacks are tech active.
Oh, well, at least it's bound reference.
Yeah, I'm gonna have to start putting that together as well. So
Yeah.
do you have any advice? Oh, sorry, I know to your time. Do you have any advice for bound reference? Or
Yeah,
do
I
you like
mean,
have an example one?
If it helps, you can basically print off all of the little modules that are relevant to whatever you want to use in your bound reference and just kind of stick those all together in a reference. I
Yeah.
kind of wrote them with that in mind for two separate people. One, for people who want to use the entire thing end to end and have all the explanation in there. And two, I've also got those summaries at the very end, which is like a little 1-pager, maybe a 2-pager on just what's key about that particular topic, so you can minimize what's in there. So depending on what you want to do with that, you've basically got those to print off as you see fit.
Sounds good.
Because it's really hard to make a
Awesome.
bound reference for everyone, because if you do, you basically put
Yeah.
everything in there, and then it becomes, I've done it before, it's like a
I mean,
mega
I've
document.
had people that just take the whole textbook.
Yeah,
and then
no,
say, okay.
I actually did that for one of them, I think. Like, pro tip, bound reference, like, I think I said this before, in my actual exam, when I could bring it in, I looked at it once. Like, you just don't use it.
I mean, I feel like it's more application. They're not really, because they know you're taking a bound reference in, so they're not going to test you on stuff that they know you can kind of just pull out of there.
Yeah.
So.
A lot of what you need is on the reference sheet. And my friends would always joke about this, and I kind of agreed, which was, if you're using a bound reference a lot, then you kind of aren't really ready for it.
Yeah.
So it's really just there as like okay, I know I've got it if I need it. But, in reality, you pretty much never refer to it.
Yeah.
Unless you
Honestly,
want to
for
do a
the
quickly
bound,
check. But yeah.
Yeah, honestly, for the bound reference, I might just use the summaries that you use, because they're like 10 times better than the textbook, which is like way too complicated and stuff. No, I'm really being honest. Like, I really like how you just like list the steps. Like,
Yeah.
I wish the textbook was that simple, but they've got to, I guess, do it their own way.
Yeah, like it's easy to rag on the textbook and be like, oh, I do things so much better. But in reality, not only are they trying to teach the thing, but they also have to come up with like a billion different questions for you to do as well.
Yeah.
And chuck it in there, plus write solutions to all of them. I only have half the job, so I can devote a lot more time to explaining things in more detail.
Yeah. That's
So
fair enough.
it's like almost a supplement to the textbook. The textbook gives you all the places to practice, and I give you stuff to teach you the concepts better.
Sounds good.
Sweet.
Thank you then, Chris. I'll see
no
you
worries.
tomorrow night.
See you tomorrow.
See ya.